Hello, this is Stephen Whitfield with Drilling Contractor. Today I'm joined by Pradeep Ashok, founder and CTO of technology startup Intellicess, to talk about data-driven performance optimization in the drilling industry and the role his company plays in helping operators and drillers make the most out of their data. Dr. Ashok, who is also a senior research scientist at the Rapid Drilling Automation Consortium at the University of Texas at Austin, spoke about these topics for a feature article in the July-August edition of Drilling Contractor. Thank you very much for joining me today.
Thanks for having me, Stephen.
So my first question is about Intellicess. Could you talk about what the company offers and how those offerings help to optimize data on the rig?
The core offering of Intellicess is basically a product called Sentinel RT. Sentinel RT is a drilling advisory backend engine that can pretty much be installed on any type of platform. So a lot of operators install this on their backend offices. A lot of the EDR providers install this within their EDRs. And basically, even the drilling contractors can use this. Now, Sentinel RT helps primarily on three aspects. One, it helps reduce invisible loss time. Second, it helps reduce non-productive time. And third, it helps reduce or it automates a lot of the calculations and reduces the workload on the drilling engineers and the rig crew on site. And I'll give you short examples of each. So for example, one thing that Sentinel RT does is it does weight-to-weight and slip-to-slip calculations on the fly in real time. So when this is actually shown to the driller in the driller's shack, basically the driller is able to self-correct and monitor their own performances. So this, in a sense, kind of helps reduce invisible loss time. Now, another example is where Sentinel RT is always trying to push the driller towards a higher ROP and only backs off when there's a drilling dysfunction. And so by pushing the driller to kind of maximize the ROP, it's ensuring that some of the invisible loss time associated with drilling is reduced. And at the same time, by reducing the amount of dysfunctions that's actually happening by alerting the driller, you're also kind of trying to make sure that the bits, the mud motors, and the tools don't fail and result in a needless trip out. So there, essentially, it's helping reduce non-productive time. Now, of course, when you drill faster, there's a lot of cuttings getting accumulated in the hole. And so hole cleaning is important. So Sentinel RT has within it a Bayesian belief network model that monitors hole cleaning and tells the driller and the crew at the rig site when the hole is not clean so that they can take corrective action. Here again, the goal is to basically prevent incidents such as stuck pipe events. So those are kind of related to ILT and NPT. Now, as an example of where Sentinel RT is useful for reducing or automates the calculation so that people don't have to do it, it actually does the talk and drag modeling and simultaneously picks up the real-time data and plots the pickup and slack up points on those plots. So these are things that usually take some time with manual kind of data handling. So these are all things that Sentinel RT kind of does out of the box. And so when this is kind of implemented at a rig site, it generally helps drill the well at a lower cost.
You mentioned the Bayesian network and the belief system that's kind of at the core of that. Could you explain in a little more detail what a belief system is in the context of a drilling operation? What makes this unique?
The belief system that you see within Sentinel was our effort to actually personify a drilling advisory system. So humans in general, they make their decision based on beliefs that they have, right? And essentially, we form beliefs over our lifetime. The place that we were brought up, where we studied, who we meet, what we read, all of these go into forming our beliefs. And this is the basis for the decisions that we make. Now, Sentinel RT does something very similar. It's just that it uses a physics-based model and looks at patterns in the data to form beliefs about various things happening at the rig site. For example, beliefs about whether a sensor is faulty, whether there's a drilling dysfunction, what the rig state is, etc. And so this belief is what it essentially communicates to the driller. And what we have seen is that we need to actually make it very simple so that it's usable. And these beliefs are actually values between 0 and 1. And these beliefs become better as Sentinel ages. So Sentinel is just like you could think of it as a digital human person that's at the rig site. And basically it's providing advice to the driller and the rig site supervisor. And essentially, after a while, it takes a while for the driller and the rig site supervisor to believe what Sentinel says. But once they believe it, they just understand that's just another kind of person. So it's kind of a personification of a drilling advisory system. And what we've seen is that basically Sentinel just becomes wiser with age, just as human beings become wiser with age. So that is essentially the concept that we use within Sentinel.
So my last question is a little broader, and it's just sort of about looking ahead. What would you say is the next step change in data-driven performance optimization and drilling? What do you think are the biggest challenges to realizing that step change?
Got it. Yeah, that's a very good question. If you look at the data-driven optimization landscape these days, you will see that real-time drilling advisory is quite mature. Of course, it's not been adopted by a lot. There's still a lot of operators and service providers and contractors who need to adopt them, but it's mature technology. What is coming next is something that's actually going to even provide a lot more cost savings. And it actually means basically trying to learn very quickly from an offset well or the well that was previously drilled or even the previous BHA run, right? So basically, let's say you just drilled an intermediate section and you tripped out, right? You want to be able to use that information during that run. That includes drilling data, that includes the bit images, that includes BHA information to make decisions about the next run so that you can optimize that. So today, that process is very manual. So somebody has to look at the bit, somebody has to look at the data separately, and then make decisions. And almost never is there a case where decisions get taken in like an hour. Like, okay, go change the bit, right? So that's what needs to happen. Basically, rapid learning. And there are major challenges to making that happen. And one of the major challenges is that data is still very siloed. So all the operators and the service providers, they still have different data architectures. So maybe somebody stores bit images on their phones, somebody stores it on a computer, somebody stores BHA data on a different computer. The real-time data is somewhere else, right? And they are all different architectures. So it's very difficult to write an algorithm that is scalable across the industry. And that's kind of hurting the development of such algorithms. But there is also a solution, basically in the form of OSDU. OSDU now stands for Open Subsurface Data Universe. And it's basically a consortium of operators and service providers and drilling contractors, everybody coming together to kind of set a common data architecture. And they're making quite a lot of progress. So when this matures, now you have a common data architecture and people can start writing algorithms to basically do the kind of rapid learning that I was just mentioning.
Well, Dr. Ashok, thank you very much for speaking with me today. There's a lot going on in data-driven performance optimization, a lot of interesting developments, and we'll be looking forward to seeing more of what Intellicess has to offer moving forward. Thank you for letting us in on how the company operates.
Thank you very much.
And thank you for visiting Drilling Contractor.